Section 4.1 Inverse functions. One-to-one functions. Suppose we define the function. We have the set f. We have a 5 orders pair here. And then we want to form another set of order pairs from this set of f. What we're gonna do, we're gonna interchange the x and the y values. So you could think about it, you're gonna flip it. Okay, so -2 and 2 will become 2 and -2. And this guy will become 1 and -1. Okay, we're gonna flip the x and the y values. And we call this set the G. Okay, so you're gonna see for each order pairs, I'm gonna interchange the x and the y value here. And we say the set G is called the inverse of f. I want you guys to highlight here. G is called the inverse of f. For a function f to have an inverse, f must be a one-to-one function. Okay, so you guys know the function f and the function g here. They are the inverse of each other. And to qualify to be the inverse functions, the function f must be one-to-one functions. And then the relationship between the functions and inverse functions, you could think about it, they just interchange the x and the y values. And also, for each y values correspond to only one x value, and each x value corresponds to only one y value. This means the one-to-one functions. Look at this example. You could see I do have a 2 and 3 here. But both of them is going to go to the 7. So we do have order pairs 2, 7 and 3, 7. Both belong to the functions. And so this is not the one-to-one functions. How about this one? This is the one-to-one function, right? Each x value will go to only one y. Okay, one x, one y. So this is the one-to-one functions. So we should be able to find the inverse for these example, okay, but not this one because this is not one-to-one function. A function f is a one-to-one function for elements a and b in the domain of f. When a not equal to b implies that function of a not equal to function of b. This is the definition of one-to-one function. If a not equal to b, implies that f of a is also not equal to f of b. And then we could write it in another way. We could say that f of a equal to f of b implies that a equal to b. If we want to find the one-to-one function, we could set it up like f of a equal to f of b. Once you solve it, you should find a equal to b. If this is true, then this is going to be one-to-one function. So let's look at this example. Decide whether the functions are one-to-one. Okay, so we have a f of x equal to -3x plus 7. So we try to use this part. F of a equal to f of b implies that a equal to b. Okay, so we're gonna plug it in. F of a means -3a plus 7 will be equal to f of b. So we do have a -3b plus 7. Now, we try to simplify. We're going to subtract 7 for both sides. And then we're going to divide it by -3 for both sides. So we find out a equal to b. Okay, so this is going to be the one-to-one function. Okay, try this example. This one, we may want to use this theorem to solve it. A not equal to b implies that f of a not equal to f of b. Okay, think about it. I do have an x squared here. When we have a negative number for the x, when you take square, the negative is going to be goes away. So let's let a equal to 7 and b equal to -7. Okay, and we already know a is not equal to b, right? One positive, one negative. So it's supposed implies that f of 7 not equal to f of negative 7. Okay, a not equal to b implies that f of a not equal to f of b. So first, we're gonna plug it in, x equal to 7. We're gonna plug in a in here. And then at the same time, we're gonna plug in b equal to negative 7. Okay, and then we're gonna calculate it. This guy, that will become square root of 49 minus 49, which is gonna be equal to 0. And this guy, negative 7 times negative 7. So we have a square root of 49 minus 49. And it's also equal to 0. See, this is not true, right? When we have an a not equal to b, it implies that f of 7 not equal to f of negative 7. But now they are equal to each other, right? We have a 7 not equal to negative 7. But the function of 7 is equal to function of negative 7 equal to 0. So we know this is not one-to-one function. Okay, horizontal line test. If it is impossible to draw a horizontal line that intersects a function's graph more than once, then the function is one-to-one. For every one-to-one functions, an inverse functions exists. So when you have the graph, you could try to use the horizontal lines. Okay, you're gonna draw the horizontal lines to see if you have a more than one intersection point. If you do, then this is not one-to-one function, so you won't be able to find the inverse functions. Let's look at this example. So I could tell this graph is gonna be decreasing for the entire domain, right? So when I draw the horizontal line, I only intersect one point. So this is one-to-one function. But this one, this is gonna be parabola, right? It's going downward. When I draw the horizontal line, I intersect more than one point. So I know this is not one-to-one function. One-to-one functions. Notice that the function graph in example 2a decreases on its entire domain. In general, a function that is either increasing or decreasing on its entire domain, such as f of x equal to negative x. So this is the linear equation. There will be a straight line, and then the slope is going to be negative. It looks like this guy, but pass through the origin. Okay, and this one, g of x equal to x squared. So remember how to graph this? This is the odd number. The leading coefficient is going to be positive. So the graph is going to be going like this way. All right, it's just similar to this guy, but it's going to be rise to the right and fall from the left. Okay, going like that. So you know this is going to be one-to-one function. And this one, h of x equal to square root of x. Square root of x, so it's going to be going like this. Okay, going like that. So this is going to be one-to-one functions either. Okay, this is to keep increasing. This is going to be increasing also. And this is going to be decreasing for the entire domain. So all of this must be one-to-one functions. Test to determine whether a function is one-to-one, so that f of a equal to f of b implies that a equal to b. This means that f is a one-to-one function. So in this example, we saw that f of a equal to f of b, and then we find it out a equal to b. So this is gonna be the one-to-one function, right? And then number 2, in a one-to-one function, every y value corresponds to no more than one x value. To show that a function is not one-to-one, find at least 2 x values that produce the same y value. So this is talking about this guy, right? we have a two x values that produce only one y value. Both of them is going to be equal to 0. So I know this is not the one-to-one function. And then number 3, sketch the graph and use the horizontal line test. So just like this one, okay, we could graph the function and then try to apply the horizontal line test. Last one, if the function either increase or decrease on its entire domain, then it is one-to-one. A sketch is helpful here too. This is what we just talked about, these 3 functions, right? They are increasing or decreasing on its entire domain. Inverse functions. Consider the function I have a f of x equal to 8x plus 5. And then g of x equal to 1 over xx minus 5 over x. Let us choose an element from the domain of f, say 10. Okay, let's plug in x equal to 10 and find it out what's f of 10 here. So we plug it in. We're gonna get 10 f of 10 equal to 85. Okay, we could write it like the order pair. Okay, parenthesis 10, comma 85. This is represent your x. This is represent your y. Now we're gonna find it out 85. Okay, we're gonna plug in of g of x here. Okay, g of 85. Simplify it. And then we do have the same denominator. So it's going to be 80 over 8, which is going to be go back to the 10. So by this coordinate, that will be parenthesis 85, comma 10. Remember from the beginning, we say we do have a set of f. We do have order pairs. And then we interchange the x and the y values. That will become another set of g. And we say f and g are inverse functions. Okay, exactly the same case in here. We have a 10, 85, and then we switch it, then we're gonna get 85 and 10. So we believe f of x and g of x, they are inverse functions. And also, these two equations, they are linear equation, right? Linear equation is always one-to-one functions. So look at here. Starting with 10, we have a x equal to 10. And then we're gonna plug into the f of x. And we find out we do have the output 85. And then once we plug in 85 to the g of x here, we get back to the 10. Okay? So these functions contain inverse operations that undo each other. So we do have a 10. We're gonna go back, do it one more time. You're gonna see we're gonna keep going to this circle. And we call this is going to be the inverse function, okay? Has further examples, check that. F of 3 equal to 29 and g of 29 equal to 3. So you know these two guys are the inverse function also, right? They interchange the x and the y. Same idea for this guy and this one also. So in particular, for this pair of functions, we could write f of g of 2 equal to 2. And g of f of 2 is also equal to 2. So look at this definition. I need you guys to highlight these two definitions. They are talking about the same thing, these two. One is, if f and g are the inverse functions, when you plug in g of x into the f, you're going to get the x. Same idea, when you plug in f of x into the g function g, you're gonna get back the x either. Okay, that's another way to write on it. F of g x equal to x. F of g, this guy, is equivalent this one. Okay, you're gonna plug in g into the f. And then g of f x, this guy is equivalent to this one. You're gonna plug in f into the g. Then you should get back the x here. That means they are the inverse functions. And let f be a one-to-one function, then g is the inverse function of f if f of gx equal to x and g of f of x equal to x for every x in the domain of G and for every x in the domain of F. So inverse functions, let f be a one-to-one function, that G is the inverse function of f if f of g of x equal to x and g of f of x equal to x. And then the condition that f is one-to-one in the definition of inverse function is essential. So before we find the inverse function, make sure the function f, this is a one-to-one function, then we can find the inverse function. Okay, if f is not one-to-one function, then G will not define a function. Determine whether two functions are inverse. So we want to know if these two functions are the inverse. So we're gonna apply this definition. Okay, we need to check both of them. Make sure they're gonna be equal to x. So first, f of x is 2x plus 5 is a non-horizontal linear function. This is talking about this is a linear function, but not horizontal, right? Horizontal line, it doesn't pass the horizontal line test. Okay, then f is one-to-one function and it has an inverse. Okay, we have to double check of f of x if this is a one-to-one function first. And then we're gonna apply the definition. So this guy, f of g of x, means you're gonna plug in g of x into the f. Okay, what is your g of x equal to? G of x will be equal to this guy, right? You're gonna plug in 1/2 x minus 5 into here. And then we're gonna look at the function x here. We're gonna replace the x with 1/2 of x minus 5. So now we're gonna plug in the whole thing here into the x. Okay, that's a 2x plus 5. Now we're gonna distribute the 2, so we have x minus 10 plus 5. Simplify it. Okay, actually it's supposed to be equal to x, right? But this is a x minus 5. Okay, so let me try on this one also. G of fx equal to x. This time you're gonna plug in the f of x, 2x plus 5 into here. And then plug in 2x plus 5 into here, the x in here. Simplify it, distribute the 1/2. Combine the 9 terms, you're gonna get x minus 5 over 2. Both of them are not equal to x. So we know G is not the inverse of f. B. Let functions f and g be defined by f of x equal to x squared minus 1. And then g of x equal to the cube root of x plus 1. Is g the inverse function of f? Okay, first, let's check it out if the f function is a one-to-one function. This is an odd number, right? It's going to be going like that. And then subtract 1, so the whole graph is going to be going down 1 unit. So this is increasing for the entire domain. So this is a one-to-one function. So good. So now let's try to plug in the definition here. So the g of x, that will be the cube root of x plus 1. And then plug it into the f. So the cube root and the cube cancel out. You're gonna get the x. So this is good. Okay, we're gonna check up this guy also, the g of f of x. So this time, we're gonna plug in f of x into the g here. Okay, and then plug in to the g of x here. We're gonna replace the x with x squared minus 1. Simplify it first. Okay, cancel out the root. So it's also equal to x. So we're gonna say function g is the inverse of function f. Special notation. A special notation is used for inverse functions. If g is the inverse of a function f, then g is written as. You're gonna see the f, the negative one here. We call f inverse. Okay, f inverse. So instead of write down the g of x, you're gonna put f inverse of x. Okay, so when you guys look at the f of x and the f inverse of x, you know this is the inverse function. Okay, and keep in mind that the negative 1, this is not the exponent. Okay, this is not the exponents. This is just means the f inverse function. Okay, inverse function. By the definition of the inverse function, the domain of f is the range of the inverse. And the range of the f is going to be the domain of the inverse. Okay, let me work it out this one. Okay, for example, I have a f of x and then I have a f inverse of x. Okay, if the domain of fx, that will be equal to, this is equal to the range of the f inverse functions. They are equal to each other. For example, I just make up the example. My domain will be from 0 to the positive infinity. Okay, that will be equivalent for the inverse function of the range. Then this range will become on this guy. If my range here, for example, I have negative 1 to positive infinity, then that will be equivalent the domain of the inverse functions, negative 1 to the positive infinity. And these two guys, that will be equal to each other. Okay, this is the relationship. The function of x, the domain, will be equal to the range of the f inverse function. And then the range of f of x will be equal to the domain of the f inverse functions. Example 4, finding the inverse of one-to-one functions. Find the inverse of the function. We have the set g and then we have all the pairs here. So if we want to find the inverse function, first, we need to make sure this is a one-to-one function. So each x value in g corresponds to just one y value. However, look at the y here. Y equal to 5, y equal to 5. This y value corresponds to two x value. One is 2, one is negative 2. And also this 2 also. The y value equal to 2 corresponds to two x value. One is 1, one is negative 1. So we know this is not one-to-one function and does not have an inverse. Okay, try this one. Find the inverse of the function. So first, make sure if this is a one-to-one function. So x value corresponds to only one y value, right? So this is good. And each y value corresponds to only one x value. So this is one-to-one function. So now we can find the inverse. How can you find the inverse function? You could just exchange the x and the y value. Okay, like the first one, I have a negative 2 and negative x. So the inverse function will be negative x comma negative 2. We just switch the x and y. Switch the x and y. Okay, so this is gonna be f inverse. To find a formula for the inverse function, first, make sure that f is 1-to-1. Then, first step, you're gonna replace the f of x with the y. Okay, make it like y equal to. Second, interchange x and y. Okay. Number 3, solve for the y. And then at the end, we're gonna replace the y with the f inverse of x. This is called inverse function. Let's try this one. Decide whether each equation defines a one-to-one function. If so, find the equation of the inverse. So step 1, we're gonna replace the g of x with the y. Okay, so we have a y equal to 4x minus 7. And then step 2, we're gonna interchange x and y. So y become x become y here. Step 3, we're gonna solve for the y here. Okay, solve for the y. So we're gonna isolate the y here. We're gonna add 7 for both sides and then divide it by 4 for both sides. Step 4, we're gonna replace the y with the inverse, the g inverse function. So this is gonna be your inverse function. Okay, try this one. First, make sure if this is a one-to-one function. So we have a y equal to x squared plus 5. Okay, it's going to be going like that way. So good, this is a one-to-one function. And then we already replaced the h of x equal to y. Now, step 2, we're going to interchange x and y. And then we're going to solve for the y here. So we're going to subtract 5 for both sides and then take the cube root for both sides. Okay, we paste the h inverse with the y here. So this is going to be my inverse function. See, the rational function is one-to-one function. Find its inverse. So we do have a f of x here, and x cannot be equal to 5. Okay, x cannot be equal to 5. So first, we're going to replace the y with the f of x. Interchange the x and y. And then we're going to state the condition. Y cannot be equal to 5 here. Solve for the y. So first, we're going to multiply y minus 5 for both sides. And then distribute the x. So now, we're gonna isolate the y, okay? We're gonna put all the y to the left-hand side, and then we're gonna add 5x for both sides here. Now, we're gonna factor out the y here, factor out. And then divide by x plus 3 for both sides. Okay, now we're gonna state the condition. X cannot be equal to negative 3. And then at the end, we're gonna replace the f inverse of x with the y here. So this is gonna be my inverse function. Okay, now we know how to find the inverse function by the formula. And then we want to know how do the graph of a function and its inverse compare. Now we want to try to graph the inverse function. And then how could we compare the graph of function and its inverse function? Highlight this one. The graph of f inverse is a refraction of the graph of f across the line y equal to x. So if you know how to graph your function f, you could draw the linear equation y equal to x. Y equal to x is going to be looks like that. And then the inverse function will be the refraction of the f. Let's try on this example. We have the f of x, and we also have the inverse function here. So first, let's get the table for this guy. Plug in the points. I'm going to plug in 0 and 1. So plug it in. X equal to 0, I will get negative 2 here. When x equal to 1, I'm going to get 3 here. So based on these two order pairs, I'm going to graph my f of x. And then we're going to do the same thing for the inverse functions. So we're going to plug in some easy number. I put in negative 2 and 3. So you should got this. Okay, based on these ordered pairs, I'm gonna graph the inverse functions. And remember we say the inverse function is the refraction of the f of x. So let's graph y equal to x here. You could imagine that the f inverse will be the refraction of f of x. So you could imagine you're gonna put the mirror here. Okay? Okay, more example. So this is the f of x, this is the function, and then we could draw the y equal to x here. The inverse function will be the refraction of f. Like this one, the f is going to be going like this. It's half of the parabola, right? And then reflected by y equal to x. So it's going to be going like that way. Okay, important facts about inverse. If f is one-to-one function, then you can find the inverse function. Domain of f is the range of the inverse of f. And the range of f will be the domain of the f inverse. Okay, they're going to exchange. Domain of this guy will become the range here. The range of this guy will become the domain of the inverse function. If we only have the order pairs, after we check if f is a one-to-one, we could just switch the x and y, flip it, that would be the inverse function. And this is how we use the formula to find the equation of the f inverse function. Okay, we replace f of x with y, interchange x and y, and then solve for the y. That's it.